Okay, so again the question is, I have the region, I have a region bounded by the curves R1 of theta and R2 of theta, and by the two areas at alpha and beta. And the question is, what is that area, right? Now, can someone tell me what is this area? What's the value of this area? A. Oops. Everybody is clear on the question now. Someone is saying R2 minus R1. You want to be more? Okay. So that's what I was looking for. Notice that the area between the two curves, right, is the same as the area bounded by R2 of theta, the two areas, minus the area bounded by R1 of theta and the two areas, right? Do we know how to find the area bounded by just R2? Yes, because of what we had previously. So we know that this would be alpha to beta half of R2 squared d theta minus alpha to beta half of R1 squared d theta, right? So the area bounded by the graphs of R1 and R2 of theta and the two areas at alpha and beta is given by this this formula. Now we can combine the two integrals as what? Is it okay to say that I can combine them as half R2 squared minus R1 squared d theta? So basically the formula is, before the formula was half of radius squared, now the formula is half of outer radius squared minus the inner radius squared. Now sometimes in the exams students make the following mistake. Instead of writing R2 squared minus R1 squared, they will write R2 minus R1 whole squared. Okay, that's going to be a mistake. So let's look at an example then. Everybody is clear on this, how to find the area. Now let's look at an example. In this example, what I have two curves. The curve R equals to 1, that's just the circle of radius 1 centered at the origin. And then remember I drew the graph of R is 2 cosine theta. The graph of R is 2 cosine theta is what? The graph of R is 2 cosine theta. That's a circle centered at, remember we multiplied both sides by R, we converted to rectangular coordinates, and we found out it was the equation of a circle of radius 1 centered at 1, 0, right? Centered at 1, 0. So the center is at the point 1, 0 on the x-axis, and the circle has radius 1. Everybody's okay. And the center will be on the other circle, right? Because the other circle has radius 1 as well. So is my picture clear to you? Now, what we need to find here is the area that I highlighted in green. So I have two curves. So this region in between the two curves here, that's the area that I want to find. So I have one curve that I highlighted in I think it's magenta probably. The other one is in red, right? So what's the area in between? How do I find those areas? Anybody? How do I find the area between the two curves highlighted in green? In order to find areas, right, we have to have a region like this, right? What's the region? It's bounded by two arrays, bounded by two curves, right? It's clear what are the two curves, right? But what are the arrays? What are the arrays? You don't have to switch. What are the other arrays? What are the other arrays? What are the arrays? Like, how do you find the arrays in this case? Is it clear, for example, that that the one array should be this, and the other array should be this, right? Basically, you're looking at the points where they intersect, right? Where the two curves intersect. Now, can someone tell me what array is this one? So what's the theta value here? And what's the theta value here? How do I find those? How would I find those theta values? Well, not so clear. Not so clear. Let's see how. I am basically trying to find the intersection of the two curves. So, for what values of theta do these curves intersect? How do I find that? How do you find the intersection of two equations? Well, in this case, what should I do? I have from the first curve is r is 1, right? The second curve is r is 2 cosine theta, and I have to find the intersection of the two, right? What should I do? Yeah, so you want to plug in r equals to 1 in the second equation. So if I do that, I get 1 is 2 cosine theta, and then cosine theta is half, and cosine theta is a half. And so can someone give me an angle? Can someone give me an angle in the first quadrant for which cosine theta is half? What's that? 60 degrees, right? Which is pi over 3. And can someone give me angle in the fourth quadrant, negative angle? Negative pi over 3. Okay, so if I pick these angles, right, make sure, so once you pick this, you need to make sure that as theta varies over this interval of theta, you are sweeping out the area, okay? So r equals to 1 curve is pretty clear, right? Because it's always r equals to 1. So as theta goes from negative pi over 3 to positive pi over 3, you are tracing out this red curve. How about the other one? R is 2 cosine theta. Are we tracing out the magenta curve as theta goes from negative pi over 3 to positive pi over 3? Well, if you look at it, as theta, when theta is negative pi over 3, right? What's the value of r? It's 1, right? And when theta is 0, it's 2, right? So is it making sense that the radius is increasing, right? And then, r is increasing, not the radius of the circle. When I say radius, I mean the r value. And then as theta goes from 0 to positive pi over 3, what is happening? 0 to positive pi over 3, then r is decreasing, right? Which is happening here. So you can analyze what, everybody sees how you check that the curve is traced out. Okay, here's you're looking at r is 2 cosine theta, right? R is 2 cosine theta. So what I'm saying is, let's look at 0 here, and let's look at 2 pi here. So pi is right about here. Well, we don't have to go all the way there. Sorry. Let me change this. Sorry. All I care is what's happening between negative pi over 3 and positive pi over 3. So let's say I have negative pi over 3 and positive pi over 3. And I want to know what is happening in between. So let's say 0 is right here. Is cosine function increasing or decreasing in negative pi over 3 to 0? Increasing. R is increasing here, and you'll see that R is decreasing here, right? So what's the value of R here? 2, right? What's the value of R here? 1. What's the value of R here? 1. So I can see that it starts at 1 and then it increases up to 2, which makes sense. And then as it goes from this 0 to pi over 3, it's tracing out the other half, right? Everybody's clear? All right, so now we know what R is. So now what's the area? What would be the area then? What integral? The integral will go from negative pi over 3 to positive pi over 3, and then it'll be half. And what should I be writing here? 2 cosine theta first, right? Cosine theta. And then the inner radius is 1. Okay, so that's all I have. And what should I do here? Negative pi over 3 to positive pi over 3, half of, what is that, 4 cosine squared theta minus a 1 d theta, whoops, and multiply out with the half, you get what do we get? We get 2 cosine squared theta minus a half. And what should I do about cosine squared theta? What should I do with that? 2 cosine squared theta becomes what? If I want to integrate that, right? What's that? Remember, even power of sine and cosine, what trick is used? Yeah, so we will replace cosine squared of theta by half of 1 plus cosine of theta, 2 theta, minus a half and we have negative pi over 3 to positive pi over 3. Notice that I'm going to get a 1, right, when I multiply out, right? I mean, 2.5 cancels out, right? So I'm left with a 1, and then 1 combined with the negative half will give me a positive half, and then I have cosine of 2 theta as well. And what's the value of that? What's the integral of half? Half theta, right? And what's the integral of cosine 2 theta? Integral of cosine 2 theta is? Just sine 2 theta? 1 with the half, right? Half sine 2 theta. Pi over 3 and negative pi over 3. Okay? And this is equal to what? If you plug in pi over 3, so you get a pi over 6 from half theta. And when you plug in pi over 3, you get sine of what? 2 pi over 3, right? Which is what? Whoops, So I get a half times what? What's that? Radical 3 over 2. Okay, so that's all I get from by plugging in pi over 3. And what happens when you plug in negative pi over 3? You get negative pi over 6, right? And then plus a half times, now it's sine of that, right? So when you plug in negative pi over 3, what do you get? Sine of that would be sine of negative 2 pi over 3, right? And what's that? Sine of negative theta is negative sine theta, right? So this is what? Well, it's a negative radical 3 over 2, right? Everybody's okay? Questions on it? Alright, so basically then when you multiply out you get a plus plus, so this is basically twice. So what do you get? If I get pi over 3, right, when I add pi over 6 and pi over 6, and then plus root 3 over 2, right? Everybody's okay? Questions on what we did? No? Okay. Okay, any questions on this example, anyone? Any questions at all? Okay, so what I want to do next is do another example. And for this example, I'm going to go back to one of the examples that we did before, which is this 4 loops here, and that was the graph of r is cosine 2 theta, right? So what I want to do, what my question next is, my next question is, find the area of one loop of the curve. I should say find the area inside one loop, I guess. So let me change that a little bit, okay? Find the area inside one loop of the curve r is cosine of 2 theta. And let me remind you that we are talking about this curve, right? So what's the area inside one of the loops? So how do I find that? How do I find the area inside one of the loops? Well, I have to think of this region as a region which is swept out by the polar axis between 2 arrays, right? The question is, well, it's bounded by one curve, but what should I pick for, what are the arrays in this case, right? So one of the arrays would be what? Clearly one of the arrays would be tangentially like this, right? And another array I can think of, okay, the other array I can think of, let me use something, maybe use red here. I can think of, instead of finding the area inside of the entire loop, how about I find area of half of it? So how about, because this region is symmetric about the x-axis, so if I can find the area of half of it, I can multiply by 2, right? So notice that, remember when we drew this curve, right? You have to remember how you drew it. When we drew this curve, at 0 I got this point, right? At what value of theta did I get this point? Was that? Pi over 4, right? At pi over 4, so I started at theta equals to 0 at this point, right? And then as theta goes up to, when theta goes to pi over 4, I am sweeping out this part of the curve. You have to remember that. Or you have to do it first, sketch out, and then do this problem, okay? So we are sweeping out the upper half of the loop as theta goes from 0 to pi over 4. Is that clear? Yes.
I just have a random question.
Yeah.
So if you were to do this,
yeah.
Is there a way that you could have your limits, like your alpha and beta, could you make that 0 and 2 pi? Integrate.
Okay, you are going ahead of me.
The whole thing.
You're going ahead of me, and I was gonna point that out later.
Okay.
The reason I didn't want to point that out is because what you just said wouldn't work for every problem. Okay, so here I'm just trying to make sure that I tell you that you need to make sure that you're sweeping out your region, okay, exactly once. The way you should pick your theta values is that you make sure you're sweeping out the region exactly once. And so in this case, we are going to take it from 0 to pi over 4. I could have also picked another area here and make it negative pi over 4. If you can check very easily that at negative pi over 4, you'll be here, and then at pi over 4, you come here. Okay? Yeah, so if I take 0 to pi over 4, then what's the area? What is the area then? Anyone? What's the integral then? Integral from 0 to pi over 4, and I should be taking half of cosine 2 theta square. In this case, the inner radius is what? 0. The inner radius is 0. You can think of the inner radius as 0. And well, this is giving me the area of only half of the loop, right? So I have to multiply by 2. Okay, so then 2.5 cancels out, so I get 0 to pi over 4, and cosine squared of 2 theta d theta, and then I get the integral from 0 to pi over 4. Cosine squared of theta is what? 2 theta is what? What's the identity again? Half 1 plus cosine, this case would be 4 theta, right? And we get 0 to pi over 4, half plus half cosine 4 theta. So all I did is multiply it out by the half, and then what's the integral of half? Half theta. What's the integral of cosine 4 theta? 1/4 sine 4 theta. Very good. So this is pi over 4 to 0. The reason I didn't pick negative pi over 4 because plugging in 0 is easier. Okay, so now you simply plug in and see what you get. When you plug in 0, it's simply 0, right? And if you plug in pi over 4, then from the first term you get pi over 8. And in the second term you have 1/8 and multiplied with what? Sine of what? Was that? Sine of pi. So this is what you get when you plug in pi over 4. When you plug in 0, you get 0 plus 0, right? And so what is that equal to? Pi over 8. Any questions on that? Now, what's the area of inside all the loops? Multiply that by 4. Or as Sam was implying, that if I want to find the area of one loop, I could have said just find the area of all the loops altogether, which would be 0 to 2 pi, and then the same integrand, and that's going to give you the area of all the loops, and then you can divide by 4. Okay. However, you have to have the practice of identifying the errors. 0 to 2 pi will not always work. Okay. All right. So that's another example on finding areas. Any questions on that? Any questions at all? Okay. Please, how many of you have started your homework in 10.3 and 10.4? Some of you. Well, you better hurry up, okay? You have a quiz on Friday on that. Make sure that you do them. Make sure that you do your problems at least 3 times by the time you take your exam, okay? If you do that, that's going to guarantee that you do pretty well in the exam. Some of you are saying 3 times. I think that's minimum. Yeah.
Is this Friday's quiz the last quiz until the final?
No. There will be more quizzes. Whether they will be in the class or take home, I don't know, but there will be quizzes. Okay, any questions at all? All right, we are done with 10.4. We are done with 10.4. You should be able to start the homework and do everything, okay? All the problems. If you have questions, come by my office, and I will help you out with this. You can also email me with specific problems, and I can send you solutions too. The biggest thing that you need in this section 10.4 is be able to draw these equations in polar coordinates. If you know how to do that, everything else is easy. Okay. Okay, so what I'm going to do then is go into our next topic, chapter 11. Again, if you ask anyone anybody who has taken Calculus 2 before, many of them will probably warn you about this chapter, sequences and series, because students tend to do poorly in this chapter. Okay, it's just there is just a trend, and the reason is the material is a little bit. It's not hard. The material is abstract though. Okay, it's like you can talk about areas and stuff, so people have some more intuition, but here sometimes people don't have much intuition. But like I said, it's not really hard. You can probably make it harder by not doing the work. Okay, so if you don't do your work every single day, do your homework. When you do your homework, that's when you realize what you didn't understand. Even if you understood everything that I said, okay, if you don't do your homework right away, you really don't know what you didn't understand. Okay, so make sure you do the problems. That's my warning. If you keep your problems till the last minute for quizzes or exams, the bad things will happen. Okay, so make sure that as soon as I assign homeworks, you do them and you ask me right away the very next day. Whatever I cover, go over that at home. Very next day, ask me. Don't wait for a couple of days, because by that time I'll finish a lot more, and then by that time you'll have you'll be more confused about this material. Okay, so like I said, this is not hard, but you can make it hard by not doing the work. Okay. All right. So the first topic is in chapter 11 is sequences. Okay. So what is a sequence? Let me actually go into slideshow. Sequences. What is a sequence? Well, a sequence is just a function. A sequence. I'm going to send you all the slides. Okay. A sequence is just a function, and where the domain of the function is the set of positive integers 1, 2, 3, 4, and so on. So it's any function where the domain is just the positive integers. Okay. So for example, look at the function a of n. It is tradition when we talk about sequences. Sequences are functions. Usually we denote functions by what letters? F, G, H, right? But traditionally, when you have sequences, people denote them by lowercase a, b, c. Also, usually, what variable do we use for the input? X. Because now the input represents a positive integer, it is traditional to use n. So I have a function a of n, which is basically 2n, right? And here n is larger than or equal to 1. So that's the function, and the domain of that function is simply the positive integers. You might say, hey, the formula makes sense for other values of n. The formula makes sense when n is half. The formula makes sense when n is any other real number, right? However, I don't care about the other real numbers. All I care is that I am restricting the domain to only positive integers, okay? So this is a sequence because the domain is simply a set of positive integers. So what's the value of a at 1? 2. Value of a at 2 is 4. The value of a at 3 is 6, and so on. Now keep in mind, a sequence is, you can view this as an infinite list. A1, A of 2, A of 3, A of 4. You can think of this as an infinite list. A of 1 is usually called the first term of the sequence. A of 2 is called the second term of the sequence, and so on. Another example, B of n. B of n, the formula is n divided by n plus 1. Okay, again, the formula makes sense for a lot of values of n, but we are restricting n to be only positive, a positive integer. So what is b of 1? B of 1 is half, right? B of 2 is what? 2/3. B of 3 is 3/4, and so on. Everybody's clear what is a sequence? A sequence is a function where the domain is the set of positive integers, okay? And you can view this as a infinite list, a of 1, a of 2, a of 3, a of 4, and so on, yes?
Always starting at 1? Is it always starting at 1?
I'm going to address that issue in a bit, yes. Same question.
Can n be a fraction? Positive, right?
N cannot be a fraction. N has to be n is always a positive integer. Always, okay? And I'm going to address the question in a second here. All right, another example, a of n is n squared. And so a of 1 would be 1, a of 2 would be 4, a of 3 would be 9, and so on, right? It's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. My last example here is b of n is log of n, okay? And what are the first few values of the sequence? B of 1 is ln of 1, which is 0. B of 2 is ln of 2. B of 3 is ln of 3, and so on, okay? Now, next example here, I have a of n now is n minus 2 to the half, right? Now, notice that when n is 1, this sequence is undefined. When n is 1, undefined means the value is not a real number, okay? So, for us, this sequence is undefined because we are interested in real value sequences. So, in this case, I cannot start the domain at n equals to 1. I have to start at n equals to 2, right? So it is defined when n is 2, and n is 3, n is 4, but if n is less than 2, then this sequence is not defined anymore, right? Am I making sense? So 1 is not in the domain of this sequence. Okay, it starts at 2. The domain starts at 2. So somebody asked me, can we always, does the domain always starts at 1? And the answer is sort of yes and no. Here's why. This is still a sequence. Remember, I defined the sequence to be any function where the domain is 1, 2, 3, 4, 5, 6, and so on. But here, the domain starts at 2, right? So why am I saying that it is still a sequence? Well, the thing is, it doesn't have to be, it can start anywhere, in fact. But I can always change the formula in a way so that I can start at 1. That is, let's look at what are the first few values of A of n. What are the first few values? Well, when n is 2, that's where I'm starting. When n is 2, I get 0. When n is 1, I am getting, when n is 3, I am getting 1. When n is 4, I am getting root 2. When n is 4, 5, n is root 3, and A of n is root 3, and so on, right? So these are the first few values. You agree with me? All right. Now, what I'm going to do, I'm going to define another sequence, B of n. Now, what B of n is, in the sequence A of n, I am going to replace n by n plus 1. I am going to replace n by n plus 1. So if I do that, notice that I get n minus 1 to the half, right? So replace n by n plus 1 in A of n. Look at A of n. A of n is n minus 2 to the half, right? If you replace n by n plus 1, what do you get? If you replace n by n plus 1, you get n minus 1, right? So that's what I'm taking B of n to be, right? Now notice that B of n is defined for n larger or equal to 1, right? B of n is defined for n larger or equal to 1. Now, is B of n a different sequence than A of n? Well, in fact, no. Notice what are the first few values. The first few values are still 0, 1, root 2, root 3, root 4, and so on. Am I making sense? In fact, if you have a function where n starts at a negative integer, that's still a sequence. If it starts at 0, still a sequence. If it starts at 4, still a sequence. You can always change the formula so that you start at 1. For example, let's say in this problem here, A of n starts at 2, right? What should I do if I want to start at 3? How should I change the formula if I want to start at 3? Replace n by n minus 1, right? Replace n by n minus 1. You'll see that you still have the same sequence, but now you're starting at 3, right? What if I want to start at negative 1? What if I want to start at negative 1? What if I want to start my so right now 0 is the value at n equals to 2, right? So what I want to have is 0 is the value of the sequence when n is negative 1. Now I'm saying that it's okay to start at negative 1 because I can always change it to a positive 1. Yeah. Did you have an answer? Remember, we replaced by n plus 1 to start at 1, right? But I want to start at negative 1. N plus 3. If I replace n by n plus 3 here, whatever formula you get, you'll see that that's defined for n larger or equal to negative 1, and you'll still get the same sequence, right? The reason is we are still talking about, what's the difference between negative 1, 0, 1, 2, and the sequence 1, 2, 3, 4. There is a one-to-one correspondence, right? This is just a little bit. There is a one-to-one correspondence here. Okay? So that's why it doesn't really matter. You have infinite list. Okay? Is that making sense? But usually we will take the domain to be from 1 to infinity, but sometimes the sequence might start at 2, sometimes it might start at 0. Yeah.
What time is the first 2 minutes of class? I'm sorry.
Say it again.
The first 2 minutes of class.
Oh, first few minutes?
Yeah.
Let me show you in a second.
I ran here soon.